Welcome, ladies and gentlemen, to Griffith Observatory's celebration of the 50th anniversary of the Apollo 17 mission. In fact, we've been doing celebrations for all the Apollo missions. We started way back with Apollo 11, before the pandemic, before everything. We had quite a big celebration. And, I think we lost track of maybe one along the way here. We might have skipped one here or there. We brought some of these to you from All Space Considered. But today we thought we'd finish in style, and we're coming to you. The broadcast is originating from Griffith Observatory, but we're all remote still here. We're not able to come from the theater yet, but we do have a wonderful program, and I'd like to introduce to you Chris Butler. He's known by many of you as a correspondent or one of the key people of All Space Considered, but others might know him better as one of the artists at Griffith Observatory. But if you've seen any of our planetarium shows, you've seen Chris Butler's work. If you've seen our school programs, or if you've had a child that's gone to any of them, you've seen Chris Butler's work. And really, Griffith Observatory would not be the same without the work of Chris Butler. But one of his other many interests, of course, is space flight, and the Apollo missions I know inspired him as a youth, as they did many of us. And I'm going to turn it over to him and let him explain to you what was special about Apollo 17 and what you're in for today. So, Chris.
Oh, thank you, Dr. Reitzel. I have been involved with many of the 50th anniversary observances that the observatory has done for the Apollo missions. And one of the reasons is not just that I'm interested, but I was, in a way, involved. My father was an engineer who worked on the command service module in Downey, California. Many of the aerospace contractors who built the Apollo spacecraft and launch vehicles were right here in Southern California. There's probably many of you out there looking at this video who also had family that were involved. So I grew up going to the factory, watching the Apollo spacecraft being assembled, hanging around the vehicles and the astronauts. I met many of them back in the day. And later I went to work at the same factory. I worked on the space shuttle program myself. So over the years, I've had a chance to meet lots of the astronauts. And Apollo 17, the last of the Apollo missions, is especially important to me because I've had a chance to meet and have long conversations with two of the crew members, Gene Cernan and Jack Schmitt. So it's also kind of a personal thing. It's important for all of us to observe this last mission and understand it because it really was the end of an era. A lot of things changed. We accomplished some amazing things. The last needed to be the best. And in a lot of ways, it was. Now, before we get to that presentation, we're going to have Dr. Reitzel talk to us about something else important on this. If I'm going to be talking to you about the Apollo 17 mission, you first have to understand it really happened. It's important because we really did these things. That's what I'm telling you. If you didn't have the background of crawling around as a kid through the spaceships, how do you know that we actually really went? Was it all a hoax? There are some people who say so. But now, Dr. Reitzel, I'm going to turn it over to you and have you explain to me and to everyone, is it a hoax or is it not a hoax?
Well, we're going to have to ask that question and wonder, was this actually hoaxed? What was it not hoaxed? Let's look into this a little bit. In fact, I want to, before I forward the slides here, let me back it up and we'll get a nice clean start here for our video editors that are going to edit this down later. But first of all, something I forgot to say, Griffith Observatory, by the way, is who's responsible for bringing you this fine program today. And Griffith Observatory is owned and operated by the City of Los Angeles and the Department of Recreation and Parks. We also like to thank our nonprofit partner, Griffith Observatory Foundation. And we'd like to thank all the members, and we'd like to thank all of you for joining us today. So now back to our question. Was this all hoaxed? Could it have been? Well, first of all, a lot of people like to think that there was a studio like this setup somewhere, that it was all being filmed with various light sources and camera and Doge there to direct it all. Well, a lot of people that believe that forget that we did build hardware. There were huge rockets that were engineered and designed, or designed, engineered, and built. You can see the tiny humans down below working on this enormous rocket. Yeah, the folks down here, this was built. This isn't just fake. They had to actually build these things. They had to build the spacecraft. Here's a command module ready to go out there and send people out into space. And the gentleman there with sort of the yellowish work clothes on, well, he went there every day designing, working, and planning for this thing to get to the moon. So as far as he knew, that was the plan, or he was in on it. So let's just think about what it would take to actually fake this. All these people that I'm showing you kind of either have to be in on it, or the stuff they're making actually has to be capable of getting to the moon. All the people, the engineers down below at the bottom here, at the bottom of the LEM, the lander, they were building something that was going to go there. And notice those wheels right there. I have a feeling Chris might show you a little bit more of that later on in our talk today. That's the lunar rover being put into there. Yes, they built an electric car that was capable of driving around. So all these things were built. And, okay, so you're building all of this just to fake it. You also had to train all the people in this room to read their monitors, and they all have data that's being put out in front of them and displayed. All that data had to be faked to make it look like we were going to the moon, or we actually just went. It's one of the two. Either we went, or all these people are in on it. Again, maybe all of these people are in on the hoax. Every single person in this room is looking at nonsense on their monitors, and they all know, oh, we're really not going, but I have to keep quiet. Well, none of them spoke up and said, we're not actually going. Well, we did launch huge rockets. People up and down the Florida coast could watch this thing, the Saturn V, beautiful rocket being launched to head off to the moon. And we launched it again and again and again. Amateur astronomers could watch the various phases of the mission. So what you're seeing here is actually, I think it's a separation and a second stage ignition. So the top is a drawing somebody made of what they saw through their telescope. The bottom is an actual image that was taken, and on the left, actual images that were taken. Well, you needed to know where to point, and these rockets and technology are behaving the way they were designed to behave. In addition, this, of course, is just a drawing, and it's showing the command module and the service module behind it, with the panels being ejected off of there. Those panels got ejected off as a planned stage of something that needed to happen so that they could pull the lunar lander out of there. Well, here's an amateur astronomer's picture showing in the center the main spacecraft moving along with 4 objects floating away from it. Those trails, by the way, are star trails. They tracked where they expected the spacecraft to be over a period of time. And the stars, of course, make trails because the spacecraft is moving. And well, there you have it. You have 4 panels blasting off of it, just like it was supposed to do. So now we're designing technology that fakes us going to the moon. And it needs to be going to the moon as it does this on a trajectory on the way there, because that's what we've told the amateurs it's going to go do. So at this point, we're sending a spacecraft to the moon to fake it. Okay, maybe. And we would have had to have done that because the Soviet Union had large radio dishes. Those are actually radio receivers, just like we had. They were able to pick up the transmissions, and you have to point those at the direction where the spacecraft should be. They would have known if we weren't going to the moon, and they would have been some of the first folks to say, these Americans, they're not going to the moon. We don't know where they're going, but they're not going to the moon if we weren't really going. So we did send something to the moon. Furthermore, we took lots and lots and lots of pictures. You can go to the NASA archives and you can pull these out, and you can see how far away that lander is. And the astronaut walked all the way over to this little crater, or maybe rode the rover perhaps over to this little crater, and took this photo. So you needed to make giant sound stages. These needed to be absolutely enormous to be able to drive around an electric car. You had to dig big pits. You had to bring in different color of dirt. You've got sort of this blackish dirt, this sort of gray, reddish almost color here. You've got gray here. You've got, lighter colored rocks. So you actually have to make it look like a real landscape. It isn't just a bunch of rock that you dragged in from the desert and poured it there. This stuff needs to look like the moon. Well, where is the truck driver that trucked in all this great dirt and rock and the various colors? Where are the sound stages? It was all dumped. Where are the matte paintings You can see in the background here, these mountains. Well, if you go through a lot of different photographs, you'll find that the mountains change perspective as they drove around. So either those are real mountains off in the distance, or you had to create matte paintings, which with each of the planned. Anyway, you're starting to get to crazy amounts of work. Where are the artists that painted all this stuff? I don't think they're out there. It just seems easier to go at this point. Now, some of you might say, well, I've got questions. I've got questions. Like, where are the stars? Okay, good question. Where are the stars in this image? There aren't any. Well, here's a picture of Griffith Observatory. I'm not seeing any sky. I'm not seeing any stars. Well, I didn't expose long enough. This was too short of a picture. I can either open up the camera a little bit more, or I can expose longer. So I exposed longer, and sure enough, you can start to make out the building a little bit better. You can make out the name, our front door, the beautiful lattice work there. Well, let's expose a little bit longer. Now we can start to make out the sky. Oh, I exposed twice as long. It's a little bit longer. You can make out the clouds a little bit there. And the front of Griffith Observatory now is beginning to get a little bit washed out. So you notice that the front door there, it's a little too bright. There are areas we're no longer able to see any detail. And if I go just a little bit longer, and now we're getting a great detail up in those clouds, but the front of Griffith Observatory is completely blown out. This has to do with dynamic range cameras, even brand new ones today, although these are consumer cameras, obviously, and there are techniques you can use these days. We've got amazing things with technology. But today in 2022, very end of it, I'm not able to buy a reasonably priced camera, go to the front of Griffith Observatory, capture the clouds, which were pretty brightly lit that night, and the front of the building at the same time, and get them both with good detail. So do you think back in the Apollo program with what we sent to the moon, we could get very, very, very faint stars as well as the bright lunar landscape? Remember, that's sunlight bouncing right off those rocks in front of those astronauts. And you don't go to the moon to get a picture of stars. You go to get this picture. You want to get the moon and the Earth in the picture. You don't expose longer and completely wash out the foreground and wash out the moon so we can see stars that we could see from Earth. So the fact there are no stars out there is just a technological limitation. Now, other folks might want to say, well, what about the shadows? I've heard shadows go weird directions. And you might look in this image and say, let me get my laser pointer. Well, the shadow of this, okay, the laser pointer, let me try that one more time. Here we go. This shadow is kind of heading off this direction. Yet this shadow is headed off this direction. It looks like they're going to intersect down here somewhere. Why? Why are they pointed in different directions? And the answer, of course, is because that's what shadows do. They don't point parallel. It has to do with perspective. It has to do with the shape of the land, the slope of the dirt that these shadows are falling on can affect the direction it looks like it is. I took these pictures on my walk up to Griffith Observatory one day, and the shadows just look like they're going different directions, yet it's one sun. There's not multiple light sources. This is just what shadows do. So people that complain about shadows looking all wonky and not being exactly parallel, well, it's like it's not a completely flat piece of ground, and the objects are at different distances. So it doesn't work. You can't just check for parallel lines that way. And even parallel lines won't look parallel in a normal photograph. There's a vanishing point off in the distance that they'll point to. So anyway, long story short, people just don't understand. We learned about this in the Renaissance, but I guess some folks didn't completely come along for the ride. One of my favorite programs back in the day was Mythbusters, and they did a lot of fun things. But one thing they did is they went to, I believe it was even, I want to say it was Lick Observatory, but maybe I was just thinking they should have gone there because I know Lick has a laser. But they shot a laser beam at one of these devices. This is known as a retroreflector, and it bounces the light back the same direction it came in. So you shine a little pulse of light at it, it bounces off this, and then if it really hits the right spot of the moon, you have to hit where we landed and put these, you'll get a return signal at twice the light travel time to get to the moon, because you got to get to the moon and then come back from the moon. So light bounces off, comes back, and sure enough, if you're pointed right at one of the landing spots where we left one of these, you can get that return signal. If you don't point at the right spot, you don't get the return signal. So we left equipment on the moon that shows we were there. Now, okay, maybe we could have left it by a rover, but anyhow, we picked up rocks and brought them back as well. We brought lunar samples. These lunar samples show what are known as micrometeorite impacts. You can see these on the right-hand side. And in fact, even this little glass spherical that's formed during lunar impacts. When a asteroid smashes into the moon, it melts it and forms these little glass spheres. Well, that little glass sphere even has a couple of little micrometeorite impacts on it. That does not happen on Earth because Earth has an atmosphere that burns up all the little micrometeoroids that would have come in and smashed into Earth. So they burn up as shooting stars. On the moon, they form little tiny, tiny, tiny craters. So these rocks clearly were left out in space. These aren't Earth rocks. They came from somewhere in space. The Japanese imaged our landing site and published this and said, yeah, that's disturbed. Something landed there. They even simulated what the ground would have looked like from that spot, according to their data. And sure enough, it looks just like the ground shots that the astronauts took from back in the day. So either the Japanese are in on this, or we really went and photographed this ground. We sent the Mars Reconnaissance Orbiter to the moon to photograph it up close, because there's not a telescope big enough. I think you need something like a mile wide in order to be able to see the landing sites with any detail. Or we can send this one that had like a 1-foot telescope off there to photograph the landing sites, and you can definitely see there's equipment left behind. The ground is disturbed. You can see the descent stages. You can see footpaths. Those dark trails are actually where astronauts walked and drove the lunar rover around. And if I go forward one more here, you can see the descent module there. Now, some folks might want to know, why haven't we gone back? Clearly it was faked because we haven't gone back. Well, we have something to say about that now. You're going to hear a little bit about that today, but also just its budget reasons. You can see this is NASA's budget as a percentage of the federal budget. So you can see a big commitment to NASA and space and human spaceflight, getting to the moon after it was announced we should go. It ballooned up to just over 4%. So it's 4 pennies out of every dollar you sent to NASA was being used on the space program. It dropped down in the 70s to under a cent. It peaked in, what was that, early 90s, back of about a cent. And now, today we're still down here at like half a cent or something like that. So people complain about the space budget. It is very small. And to run all these various programs, the shuttle, the space station, you can't go back to the moon if you're running these other programs. And the shuttle was stopped. We now have commercial space flight to get us to the space station. And, honestly, it would have been harder to hoax all this. It would have been harder to fake it than just to go. And I firmly believe that. And folks that want to think we didn't go, well, let me look in the comments here. Any questions? No, we've convinced them all, Chris. We've convinced them all. So I'm going to end with the shot I just love, of this shot of the footprint in the powdery regolith of the moon. And, back to you, Chris. And now that we've convinced them all we really went, what was Apollo 17 all about?
It is nice to be talking about Apollo 17 today, because we are not just looking back. Now, for someone like me, as a child who grew up very excited about it, the tough part of talking about Apollo, while it was really exciting, well, is that it stopped, right? So there was a long period of time where we really didn't know if we were ever going to be going back. Today, the day this was recorded, was December the 11th, 2022, and something important happened today that gives a tremendous amount of hope and lets us not just look backward, but also forward. Now, after I conclude my part of the program, Jared Head will be talking to us about that, so stay tuned for that third part. Looking backward, looking forward, we've mentioned that the reason this is so poignant is that Apollo 17 was the last. It was the end of an era. Why is that so? Why was it the last? Well, there's a couple of reasons for that. Let's see here, pushing my forward button. There we go. Why the last mission? There are a couple different things, and Dr. Reitzel already alluded to one of them, which is very simple. Apollo was very expensive. And in addition to the other things we wanted to do in space, like a space station, we also had huge budgetary pressures on the United States at the time. For example, the Vietnam War was a big pressure for the United States to meet military spending at the time, and other things too. But they made the decision that they were going to curtail Apollo 17, ended up being the last, but it wasn't going to be that way. If you checked in 1969, and looked at the plans. NASA had lettered the missions they had planned, starting with an unmanned test A, then B, then C, then D, different kinds of missions. And these went on up to a G mission. And the G mission would be the first landing. That's Apollo 11, right? So a very brief stay, one moonwalk only, and then right back in the LEM, and you don't go very far. The simplest moon landing we could do, mission G. Well, they were going to follow on with that. These were the plans they had at that time. There were going to be H missions. Now, these were 2 moonwalk missions, but only within walking distance again. That's not too far, but they were going to do precision landings close to important science destinations on the moon. And the astronauts would also get a little, like a golf cart, they could pull behind them with extra tools and equipment. The plan was that Apollo 12, 13, 14, and 15 would be those kind of missions. And then the plan would be, beyond that, they'd have what they call a J mission. The J mission, we talked about that lunar rover, the electric vehicle. That changes everything. You can go much, much farther. And they upgraded other things in the system as well, supplies and so on. So you could stay on the moon for 3 days, 3 lunar excursions much farther away. What would those missions be? Apollo 16, 17, 18, 19, and 20. And they would have finished up with Apollo 20 in 1973. But a couple different things happened so that if you checked in just a year after Apollo 11, things changed a lot. And then again, we had Apollo 13 that did near disaster. You check in after Apollo 13, here's what's happened. They're only going to fly one more of those H missions, only one walking mission. That's Apollo 14. And it happened just that way. The J missions, though, they're going to get right into them and get right started with them as fast as they can because NASA canceled 18, 19, and 20. A lot of the hardware was already built for Apollos 18 and 19. 20 got canceled because of the Skylab space station. It turns out Skylab needed a Saturn V moon rocket for a ride into space, and that meant there was no ride for Apollo 20, and they'd stopped making moon rockets. So Skylab means no Apollo 20. But 18 and 19, they did build a lot of equipment. Why didn't we go? Partly cost, but also risk. Every Apollo mission had danger associated with it. We'd gotten away with it. Apollo 13 was a close call, but there were a lot of people at NASA who said, we should stop before we have a problem. We want to come back someday with a more mature system we didn't put together so fast. And that's reasonable enough. I have a lot of friends who are interested in things like Apollo 18 and 19. They built a lot of the hardware. Can you see some of it? Yes, you can. Actually, a lot of it does still exist. This is a good example. If you go to Florida, to the Kennedy Space Center, the second and third stages of their moon rocket probably would have been used to launch Apollo 18. It's a real stage. And there are other fragments, parts of lunar modules and lunar rovers, for that matter, that probably would have flown on these other missions. But for budgetary reasons and also risk management, Apollo 17 was going to be the last. Now, what is going to be made of choosing a crew? Remember, this is your last crew, your last chance. Everybody's a little bit different in the astronaut corps. You've got to pick your best people, your best. And there were 2 groups of people, 2 crews that were basically ready to go. NASA had the tradition that after you would serve as a backup astronaut for one mission, and then 3 missions later, you would be promoted to actually go. Okay, so if you backed up Apollo 10, you'd be on the crew of Apollo 13. You back up Apollo 11, you'd be on the crew of Apollo 14. Well, for Apollo 17, it'd be the backup crew for Apollo 14, would be the people expected to go. However, something happened here. Apollo 17 crew, based on crew rotation only, would have been Gene Cernan in command, Ron Evans as commander of the command module, and then Joe Engle of the Air Force walking on the moon with Gene Cernan. Apollo 18, that's the backup crew for Apollo 15, was Richard Gordon in command, Vance Brand piloting the command module, and walking on the moon with Gordon would have been Dr. Harrison Schmitt, known as Jack. Now, Jack is unusual. This is important. The Apollo 17 crew was eminently qualified, but Apollo 18, by chance, ended up having the geologist, the scientist. NASA in 1965 had picked a number of professional scientists with great publicity and everything else, and saying that we were going to send a geologist to the moon. Jack Schmitt was that person that everyone had always been expecting to go. What ended up happening is that the chief of the astronaut corps proposed the Apollo 17 crew, as you see it on the left, but NASA headquarters came back and said, the geologist goes on the last flight. And they offered the astronauts a choice. They said, look, Gene and you 17 guys, you can step aside and we'll just take Dick Gordon's crew with the geologist. That's fine, they'll go. Or Gene, commander of 17, you can tell Joe he doesn't get to go. And Jack gets his seat. That's what ended up being done. Joe was replaced, and that's why the last crew is the way it is, because it was the last flight. It meant the geologist was going to go. And I don't feel too bad for the other astronauts involved. Vance Brand commanded space shuttle missions. Joe Engle commanded space shuttle missions as well. So there's more you'll hear from them in history as well. Also kind of in the crew are spacecraft. I want to mention that. The command service module, built in Downey, remember folks, local pride, was named America. No American spacecraft since then has been named America, nice name for it. And then the lunar module was named Challenger. Now that's a name today that obviously makes you a little bit, somber and hold your breath for a moment. But remember, there have been 2 American spacecraft named Challenger, and this one does not have any sadness attached to it at all. It's not an unlucky name. Challenger, the lunar module, would end up doing very well indeed. Now, I mentioned this is the last mission. It's weird, the situation at NASA. The year that Apollo 17 was launched, 13,000 NASA employees were laid off. Most of the hardware had already been built. The commitments to Apollo were ending. They were coming down, right? So funding was going down all the time. And in fact, the minute that Apollo 17 lifted off, when it cleared the launch tower, 900 people would get pink slips and be sent home without a job. That's a tough situation in which, number one, to make sure all the engineers and everybody are really enthusiastic in doing their job. NASA was almost desperately promoting the button you see there was from my dad's collection. They handed it out to everybody saying, only a beginning. Apollo 17, it's only the beginning. And they would send the crew, especially the commander, Gene Cernan, out to talk at every kid's birthday party, anything. He would just show up at shopping malls doing this, it's only the beginning speech to keep people's spirits up. So that's kind of a weird aspect of what they had to do. And of course, the pressure. All the other astronauts that walked on the moon, they were no slouches, but the expectation was this may be last, but it needs to be the best. Now, where are they going to go? You may be thinking, moon is moon, right? You moon and you find moon rocks and you're done. But that's not how worlds work. If you landed on the Earth, and you landed in Las Vegas and got some samples, would that tell you about the Himalaya mountains or the jungles of South America? No, even in geology, just the geology of a world, you've got to choose very carefully different places to tell different parts of the story. So this last mission, and last for who knows how long, the scientists had to choose very carefully. And everybody, I mean everybody, brought up whatever their favorite site was that they've been arguing all through the Apollo program. We've got to go here, or we've got to go there. Well, this is your last chance in a meeting, guys. You need to make that sale. you'll notice that the Apollo missions, this shows all the landing sites, including 17, they're scattered around the moon. That's not an accident. Apollo specifically visited, well, relatively near the equator, about 15 degrees north and south. This is about how far north or south it could go. But the scientists were picking widely separated places in different kinds of terrain to try to tell as much of the moon's geologic story as they could. There were other candidates for Apollo 17, such as the Marius Hills. Looks like the moon has acne, all those little bumps. Those are volcanic domes. And they were proposed for many of the J missions. We never went to Marius Hills, so we don't know what we would have seen there. It's on our to-do list for the future. Also proposed for Apollo 17 was the lunar crater Gassendi in the southeast. I am back. Thank you. My audio cut out for a moment. Gassendi is completely different than other places we visited, but it too was not selected. We wanted to find a very special spot, and this is where they found. The moon there, the red circle, is the Sea of Serenity, Mare Serenitatis, and the little X shows the Valley of Taurus Littrow. The mountains around here were considered some of the most ancient terrain on the moon, and the valley floor was filled with dark material that seemed to be volcanic. Now, they didn't know if it was young volcanics or very old volcanics, but the combination of the very old and possibly the much, much newer gave this site tremendous lead in everybody's mind. So they picked Valley of Taurus Littrow, dangerous place to land. You've got to go over all those mountains, and those mountains are about 8,000 feet tall, and then drop to land in the center of that valley. The valley's about 12 miles across. So that was the site that they chose as a spectacular finish for Apollo. If you see a picture of Apollo 17's launch, you will notice it is the only Saturn V launch at night. It was launched very late at night in complete darkness. That makes it visually distinctive. Why did they do that? Well, one answer is the celestial mechanics of lining up lighting conditions on the moon at that right moment. That's part of it. But they might not have done that in earlier years with Apollo because they wanted to have daylight conditions in the event they had to fire the launch escape tower and bring the astronauts down immediately into the ocean. A night launch means you have to do that in the darkness. It's a measure of the confidence that the engineers had in the Saturn V launch system that they didn't think that was very likely. They were prepared just in case they would do the rescue at night if they had to. But this was the best conditions for getting the spacecraft to Taurus Littrow, and so for the only time a Saturn V lifted off at night. They flew to the moon, landed on the moon successfully, and that landing occurred December 11th. In 1972, the last landing on the moon. And they were right on the button just where they wanted to be in that valley. So now we come down to what did they do there? Did they just grab moon rocks? No. They had a plan, folks. This was going to be highly organized. This is a map of the valley floor there. And you can see little dotted lines indicating where they will go. The red dot indicates where Challenger is sitting in the valley floor. Let's start with the very first thing they did on what they call EVA, extravehicular activity. Number one, day one, what did the crew do? You can see a lot of what they did in this picture. The flag going up is not the first thing, not at all. And actually, I talked with Gene Cernan about that years ago. I said, didn't you want to set the flag up first? Because he's a very patriotic guy. And he said, actually, there was already a flag on the surface the minute we stepped outside because I was wearing one as a shoulder patch on my suit. So he considered the flag to already be there. I like that story. But notice behind the flag, the lunar rover is already completely set up. The guys have been busy for a while. They got out and immediately started deploying equipment and assembling the rover. It folds out from the side of the lunar module, and equipment has to be put on it. So Jack and Gene have been busy here for quite a while before they set up the flag and, of course, take the appropriate pictures. Jack Schmitt was especially busy here as the geologist. He was setting up what they call the ALSEP, or Apollo Lunar Surface Experiments Package. These were a whole series of experiments that had a nuclear power supply, a little compact RTG as it's known, and he took these off at a predetermined spot, set them up, was hooking up the cables, all the different instruments. We might have talked about ALSEP before on other Apollo missions. I should point out only one of the experiments had ever been flown before, which is the heat probe, if you're wondering. All the others are new. Why? It's our last mission. They're trying a lunar surface gravimeter, great word, gravity measuring device. Experiments on dust particles to see how fast dust particles move near the surface of the moon. Magnetometry experiments. Geophones that would listen for sounds. It's like the InSight lander on Mars. Same sort of thing. A whole new suite of instruments. Jack set those up on the first day. And you can see here in orange, they didn't go very far from home. They stayed pretty close by. I want you to take a moment and look at the scale meter. There's a little black and white striped scale meter at the bottom there. And that shows distances in meters. Remember, that valley is 12 miles across. The small little dashes in that scale meter are 300 meters for each little black and white section. That's the length of a nuclear aircraft carrier. To give a sense of scale, or the Empire State Building laid on its side. Now, so even this little thing in orange, that little EVA1, that's not that big. You wait and see what's coming next. So day number 2, I hope these guys ate their Wheaties, because this is what they're going to do. They're going to drive in that electric car all the way to the mountains on the southwest side of the valley. Here they're going to be looking at all kinds of different geologic features. Of course, they want to sample the mountains. There's an important cliff, a fracture in the landscape called the Lee-Lincoln Scarp. They're going to go to that. And then you notice the bottom of the picture in the bottom left is all lighter color. They call it the light mantling of this. It looks like some new deposit of something has been draped onto the surface. Some scientists proposed that this could be ejecta blown out of a crater, Tycho, all the way on the other side of the moon that could have been draped across the valley. So they're going to be investigating all these things. Before they get started, they had a problem the first day when they set up the rover. Gene busted a fender. It had happened on Apollo 15. It had happened on Apollo 16. Everybody caught something on the dumb fenders and busted it. Sure enough, he did. He had duct tape, I swear, duct tape. And he tried duct taping it back on there and so on, but it wasn't a very good fix. So John Young, an astronaut back on the ground in Houston, did experiments and realized you can use a clamp and 2 of the maps you no longer need and make a new fender. Because this worked so well, it kept dust off the astronauts while they were driving, at least mostly, and it got both Gene and Jack a lifetime honorary membership in the American Auto Body Work Association. So they got a special award for fixing their vehicle. At Station 2, the work began. That's on the slope of the mountain. You can see the mountain there behind Gene. Station 3, again, that's actually on the side of that cliff that we talked about that they wanted to sample. Something happened here. I'm going to show you a video a little later. Twinkle toes. Do you guys know about twinkle toes? If you meet Jack Schmitt, he's still living. If you meet him, don't mention the twinkle toes situation. You'll see later. But here's some stills. It's hard to move around in those suits. It's hard. They're puffed up like a balloon against that non-pressure. These are pictures of Jack during the Twinkle Toes episode where he drops something on the ground and is trying to pick it up. One interesting note about this, by the way, this also shows the confidence we were starting to get in the spacesuits and our procedures. We were doing more daring, more physical things. These guys were really down in the dirt doing their work. Jack was fine, so forth. But this shows, the Twinkle Toes episode shows just how confident we were getting moving around on the moon. Now, here comes the big discovery. for the mission. Every single time we went back to the moon, every single time, we found something we didn't expect. That's an important point. Why did we keep going back? Because on Apollo 15, they had ideas, and some of them turned out to be surprises, right? We learned from it. Apollo 16, they got to the Descartes landing site, and it was not made up of the kind of rocks they thought. They had to improvise, and they discovered what was really there. What happened with 17? There was a crater called Shorty. That's in the inset picture seen from orbit. The little picture, you see it has a dark halo around it. Some people are thinking that might mean it's not an impact crater where a meteorite hit, but that it's a volcanic vent, a little mini volcano that's blown stuff out from inside the moon. Well, they drive up to Shorty, and Jack finds at his feet, you see it there on screen right, orange soil. And the moon is a notoriously Ansel Adams planet. It's all black and white. But it has subtle colors, but this was not very subtle. It was orange. And immediately they went into high gear, started sampling these things. And I'll tell you, initially they were thinking, yeah, maybe it's really a volcanic alteration of the landscape. Maybe that's what this is. We're looking for the new things on the moon. Maybe we found a new volcano. Well, it wasn't like that. It was volcanic, though. It was volcanic. It's volcanic glass, tiny little beads of orange glass that were blown out of what they call a fire fountain on the moon. But it was more than 3 billion years ago, and deposits of this still are in the soil down there. And this was excavated by Shorty Crater and gotten up to where they can get it. So a very exciting result for that part of the mission. Coming back towards the lunar module now, at the end of their very busy day 2, they stopped at Camelot Crater, and the crew named these features, by the way. Camelot Crater, look how bouldery it is there. That is some pretty ankle-breaking kind of hiking destination. Again, the confidence. Geologist Jack went straight into the middle of these, hopping amongst the rocks and sampling them, where maybe on the first moon landings, they'd be scared to approach them. Right? But now we're getting more confident. The last EVA is going to be the last Apollo EVA of all. What are they going to do? They're not going to retrace their steps. They go the other way. They don't go southwest. They go northeast to the other mountains, the North Massif, these 8,000-foot tall mountains, and they've got a particular target in mind. It looks like boulders have rolled down the side of this slope. They'll sample the slopes at the bottom of these mountains, drive up as far as they can and still be safe. But boulders have rolled down from the top. They can get to those. These are made of rocks that were at the top of the mountain. They can't get there. It's not safe to drive the rover, but they'll visit one of the boulders down there. And that's why you have this famous picture. We've already seen it. This is one of those boulders at what we call Station 6 at the bottom of the North Massif, where the giant split boulder. Great samples, great science, but I want to mention a personal story. Gene Cernan had a daughter, Tracy, and his little girl, he told her he would write her name on the moon, and she'd be the only little girl, now woman, of course, with her name written on the moon. This is where he decided he was going to do it. You see this shelf of dust on the side of the boulder? It's perfect. And that was where he was going to do it. But the time was so tight. They were always being pushed to do new things. He realized in horror as they drove away from this site, he had missed his chance. Now, this is his daughter at the time of the mission. And it so happens that he remembered at the very last minute before they left the moon, used his hammer and wrote TLC in the dust. And so it's still up there, still visible, and now Tracy Cernan is 60 years old, but she's still the only little girl with her helmet. Here's a picture from above, the Lunar Reconnaissance Orbiter showing, yep, that boulder really did roll down, and if you looked very carefully, you'd even see the astronauts' footprints right where they said they would be. Finishing up here in the north, there's a picture at Station 7 looking all the way across the valley. By the way, they're looking straight towards the lunar module there. Good luck spotting it. It's tiny. It is a tiny, tiny little dot in the image. They were a long way from that lunar module. Here's a picture at the Station 8 before they turned around and came back home. Again, the lunar module is just incredibly far away. At Station 9, here's a picture of Jack Schmitt trying to get into the vehicle in low gravity. Apparently, you have to jump up and sideways, throw yourself into the thing, and eventually you probably stop somewhere near your seat. So that's a picture of Jack there. Now we wind up the mission with their appropriate words and so forth. They come back to the lunar module, and we have a televised blast off from the moon. A very successful mission. There were no significant dangerous episodes, and there were very important scientific discoveries. Of course, we weren't done with the mission yet. Everybody might be very happy. And of course, here's some pictures of the crew on the way back home, everybody looking very content. But we did have the question of the heat shield one more time, and the parachutes one more time, nail biters at the last minute, but it did all work out. And the crew was able to land very close to the USS Ticonderoga, and the crew came home. So a successful ending and a spectacular one for the last mission. What about legacy? Well, there's a couple of stats I can throw at you. The length of the flight was 12 days, 13 hours, 51 minutes. They spent 22 hours and 4 minutes walking on the moon in 3 EVAs. The lunar rover went 22.2 miles. By the way, that's almost exactly the distance from the Griffith Observatory to the ocean, to Long Beach. Just picture yourself strapped on that rover driving from the observatory to Long Beach. It's amazing. And they came back with 254 pounds of samples. The asterisks indicate record value. Every one of these is a record. There's some other long-range echoes of Apollo 17. I already mentioned one of them, of course. The second of the space shuttles to fly in space, Challenger, of course, bore the same name. By the way, neither spacecraft was named for the other. They were both named for an oceanographic research vessel. So Challenger was HMS Challenger, as a matter of fact. The landing sites, Dr. Reitzel already mentioned, they've been photographed, and extensively. There are a few things that we can see. First of all, the crew wasn't lying about where they said they would walk, where they walked, because they actually traced on photographs. I walked over here, and then I walked over here, and I walked over here. You compare those with those little marks from where the footprints are, they're exactly where they said they would be. Also, one other thing to notice in this picture, if you look at these pictures very carefully, you will at times, not quite in this photograph, see a very small little shadow that moves across the surface as the sun moves across the lunar sky. And that is the shadow of the flag. And the flag is still standing at the Apollo 17 landing site. As far as the astronauts, I mentioned I've had a chance to meet with 2 of them. I never met Ron Evans. He passed away in 1990. Gene Cernan, I had quite a few conversations with over the years. Jack Schmitt is still with us today. You may have a chance to meet him at some event. Again, if you do, don't mention the twinkle toes thing. So there we have Apollo 17 looking back as the successful final conclusion to the missions. I do want to give you at least a moment of video. So I have 5 minutes here of video to show you a few things, including the twinkle toes situation. So here's a quick look at some video from the moon, Apollo 17.
Wait a minute. All right, I got you reaching for the flag. How's that? That's very good, Gene. Let me get it in stereo. Houston, that's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.
Okay, thank you, Dino. Copy that.
Science.
Okay, that little set of 4 samples
It looks like
is
we're
in
going to
527. Okay, we hope it was worth the effort.
And I don't, looking at the constraint lines, it's not going to do you any good.
Oh, it's all worth the effort.
Station
It hurts.
4.
Okay, and we're ready now for your fan, and don't forget your scoop.
At 4, yeah. So we can't
I won't. Ah!
do anything there. All right, but we will at 5. Okay, that sounds good.
You don't mind a little dirt here and there, do you, Jay?
Watch how hard this
No.
is.
No, dadgummit. Well,
Hey, Gene, would you go over and help Twinkle Toes, please,
I'm
Gene?
really... I tell you, you fix that camera bracket so the bags stay on, and I'll be a lot better off.
Roger.
Okay. Oh, hey! Wait a minute. What? Where are the reflections? I've been through once. There is orange soil. Well, don't move it till I see it. It's all over. Orange. Don't move it till I see it. I've stirred it up with my feet. Hey, it is! I can see it from here. It's orange. Wait a minute, let me put my visor up. It's still orange. Sure it is. Crazy. Orange. I've got to dig a trench, Houston.
Flight income. Copy that. I guess we better work fast.
His wits. It really is.
Go ahead, Inco.
We should be same color as
Temperature
these.
on the step is about 100 and,
Look at this soil for you.
temperature on the step's about 102. It's almost the same color as the LMP decal on my camera. Uniform rock type, I'll tell you. The only variation are those gray zones, which are just seem to be either finer or the absence of vesicles. Well, I'm nose to nose with a piece of it right now. Okay, it's coming off.
We don't usually get to see this.
Well, I'll set it right up here. It's gonna fall down a hill. You better stomp off a good place. Yep.
You can actually see his face there. This is from the road where the astronauts are just about to get back inside the lunar.
Bob, this is Gene, and I'm on the surface. And as I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just let what I believe history will record that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus literal, we leave as we came, and God willing, as we shall return, with peace and in hope for all mankind.
And there we have it. It's a little bit of video to actually show you some of the moments that we talked about. I want to toss things now over to Jared for the last part of our presentation, because Apollo 17 is no longer a sad story of something great we did in the past. It is, as their buttons advertised, only a beginning because of some things that happened literally just today. Jared?
Yes, and super excited to be finally at the end of that beginning, in a sense, and heading into the future of lunar exploration that is going to be happening over the next at least decade in terms of missions that have been planned out. We go from that wonderful patch of Apollo 17 to the wonderful month that we've just had with the successful launch of the Space Launch System. Oh man, we've been waiting so long for that to happen, and it was great to see a vast majority of the things with the rocket go without a hitch. In addition to that, the Orion capsule appears to have had a nearly flawless lunar and deep space operations throughout what they've done. The service module provided by the European Space Agency also appears to have had a incredibly smooth mission. And then today, just this morning, I mean, literally, what was it, like about 5 hours ago or so, Orion had its successful return from space. So going through entry interface, re-entering the Earth's atmosphere from very high velocities, heating up its heat shield at temperatures we really haven't had on a vehicle since the Apollo era, and then a successful splashdown just off of the coast of California. So 25 days of great work in Artemis 1. But what's next? After all, we've had Apollo 17 in the past, and we can also now successfully place Artemis 1 into the past as well. Well, our future for lunar exploration kind of starts out a little dark. And that's specifically because the places that we are very interested at on the moon, to return to the moon with, are these areas known as permanently shadowed regions. These are areas where sunlight does not enter. This crater is Erlanger crater near one of the moon's poles. And this is it at lunar sunrise. So this is at sunrise with it, and deep within that crater, sunlight does not reach it. That means it is extremely cold in that area. And why are these so interesting to us? Well, it's because that we think that these areas that the sun does not touch, that they could have potentially harbored ice at some point. Without sunlight touching those areas, the temperatures don't rise above, certain areas of minus 300 degrees Fahrenheit. So very, very cold, definitely cold enough to keep water ice there, let alone a multitude of other different types of ice as well. And of course, it's not just at the South Pole as well. There are some at the North Pole, but not as much compared to what we have. And having flown probes specified with instrumentation to look for water ice, it's not just a matter of could the moon have ice that we know. Well, we know that water ice is present excuse me, at the North and South poles of the moon. And in fact, if you look at this really great map of the moon here, you could see over on the left, that's the lunar South Pole, and there is significantly more water ice detected there, as we have on the right side there with the lunar North Pole. So probably going to be aiming to land towards the lunar South Pole as opposed towards the North Pole, simply because there's just a lot more a lot more ice in that area. And we'll talk specifically about why that's important in just a little bit, because it wasn't just Artemis 1 that was a recent thing involved in the exploration of the moon. No, Danuri, which is a mission from the Korea Aerospace Research Institute, they launched in August, and they're actually going to be entering into lunar orbit on December 16th, so just 5 days away during this week. And it has a special camera on board called Shadow Cam that NASA has supplied, that is going to be able to image those shadowed regions deep within those craters. So we should be able to possibly maybe visually confirm that water ice is there. Possibly. It's definitely not a for sure with that instrument, but we'll have to see what it can do. It's great. It already definitely has the instruments on board to allow us to detect water ice, and also the quantities of water ice as well, which is just as important. And then just this morning, on a Falcon 9, the iSpace mission, Hakuto R, which is a private lunar lander, which we'll be attempting in just a few months. It was launched, but there was a small NASA JPL CubeSat called Lunar Flashlight, and that was successfully deployed as a rideshare payload. And it's going to go into orbit around the moon, and it's also going to use its own instrumentation to act like its name, Lunar Flashlight, and look into those permanently shadowed regions and see if indeed there actually is water ice there or not. Now, what is very interesting about Lunar Flashlight is that its orbit actually emphasizes it going over the lunar South Pole. So that's a very, very exciting and very interesting method by which it can take a look at those areas. All right. Looking forward here for that. All right, so I think on my next one here, I've got a great view of the moon from this previous Artemis 1 mission, because this is what Artemis 2 is going to be doing, and that is our upcoming mission with that there. And what Artemis 2 is specifically going to be doing is going around the moon. It's going to be a 10-day mission doing a free return trajectory with that there. And just want to say, if anybody's got control of it, I have lost control over on my end with that there. So there we go. There is our Orion capsule, as we can see with it right there. That is the one specified for Artemis 2 to be coming up. So very, very cool that that capsule is already near completion. This free return trajectory will take the capsule to within 7,000 kilometers above the far side of the moon. And this is essentially a full crewed shakedown of the Orion capsule in lunar and deep space. This will carry 4 astronauts on board, including what would be the first Canadian to leave low Earth orbit and go out into deep space. Now, just kind of want to talk a little bit about what Artemis 2 and Artemis 3 are doing with their space launch system with this next image that I have here, which is that it will deploy CubeSats. So just like what we had with the Artemis 1 mission. And in Artemis 1, in parts of the rocket there, we were able to actually deploy with our inner stage, the connection for our Space Launch System rocket, 9 CubeSats. So there are 9 small satellites that were deployed on a mission. We've also got 10 as well here, and it's going to be really, really great to catch all of that. One of the reasons we're so interested in finding water ice and other things like that is because we want to do something a bit beyond what Chris talked about with Apollo. Apollo was great. It is a fantastic program. The technological development from it is still echoing through our society as at large today. But there were some problems with Apollo, which is that it was really expensive, and it was ultimately a program that was essentially what we like to call nowadays flags and footprints. We've got the political motivation to do it, but maybe not necessarily the technological or the budgetary motivation to do so once we did it. With Artemis, the whole idea is that we want to go back to the moon, but we want to go back to stay. We're not simply going there just to say, hey, I beat you, finders keepers or anything like that. We are going there because we want to live and work on the moon. That's why we're looking for water ice, because water ice allows you to take it. And water is hydrogen and oxygen. And oxygen you can turn into breathing air. Oxygen you can use in manufacturing. Hydrogen and oxygen together, you can use that as rocket fuel. And of course, water ice is water, and you can use that as consumables, which is very important. So it's not just about going and putting a flag and doing some cool science. We're also trying to understand what it takes to get humans off of this planet and living elsewhere throughout our solar system. So that's a pretty critical portion of the Artemis program. But Artemis 3 is going to be the mission after Artemis 2. And Artemis 3 has an additional space vehicle involved in it, and it is going to be this whole thing that you see here, which is SpaceX's Starship Super Heavy. The Super Heavy launch vehicle and their Starship vehicle are both going to be involved in this mission because SpaceX has been contracted by NASA to the tune of $2.9 billion through a commercial contract to develop a human landing system version of their Starship vehicle to bring astronauts back to the moon. Now, I think it's really important to understand that when you see a photo of the Starship Super Heavy vehicle here, you kind of really don't get the idea of the fact that the Starship spacecraft portion is about the size of a space shuttle. So this is significantly larger than the lunar excursion, than the lunar module, the LEM. That was used during Apollo. But we are still only going to be sending 2 astronauts to the surface on Artemis 3. And that's because there's a lot of things that have to happen with Artemis 3. First of all, SpaceX's idea with what makes Starship, it's sort of what the secret sauce of it is this ability to refuel it while it's in orbit around the Earth. This is something that, at least specifically with what SpaceX wants to do with refueling, hasn't been proven yet. We have been able to transfer fluids between spacecraft, both in robotic missions that have orbited the Earth. There were several tests during shuttle missions in the payload bay on spacewalks. There's even a robotic refueling mission on the International Space Station that tested this. But what SpaceX wants to do specifically is transfer what are called cryogenic fluids. So these are fluids that are ultra cold, somewhere below -250 Fahrenheit. Essentially what we often will chill our propellants and our oxidizers or our fuels and other things that actually allow our rocket engines to run. And that's really difficult because nobody's really ever tried it before in the microgravity environment around the Earth. So there's a lot riding on SpaceX and a lot of pressure on them in order to get their Starship Super Heavy launch system as a whole up and running, because the human launch system or the human landing system Starship is going to require a full tank of gas before it leaves Earth. And then it's going to loiter around the moon, where it is eventually going to have a Orion launched by a Space Launch System rocket, rendezvous with it, and then transfer 2 of the astronauts from the 4 that are on board of that Orion into that Starship human landing system, and then drop it down to the surface, do their work, and then come back up to the Orion and then take the Orion home. Now, whether that Starship human landing system stays in orbit around the moon in this incredibly complex mission, that's sort of something that is still on the table at the moment in terms of what NASA is going to want out of SpaceX with that. But you can imagine, Orion is a pretty good sized capsule compared to what it is compared to Apollo. But as you can see here, it's a little bigger. The human landing system is a little bigger than Orion is right there. And also, if you're a little bit of a space history buff, kind of reminds me of something when I look at this, right? So just a little bit with that there. In case you don't know, that's a Gemini with an Agena upper stage as a part of that later program. So I just realized that this morning, and it kind of flashed across my mind. But that human landing system Starship is going to be radically different from the Starships that SpaceX is going to fly here on Earth. The ones on Earth, there will be heat shields in order to return those Starships to use, and aerodynamic surfaces as well, so that way when it's doing its entry into the atmosphere quickly. But because the moon doesn't have an atmosphere, you don't need a heat shield. You don't need aerodynamic surfaces. So it will essentially be a stripped down version of SpaceX's Starship. In addition to that, the landing engines are likely going to be moved up towards the top. So that way, when they actually land Starship on the moon, it doesn't blow out a huge amount of regolith and generate what we call plume impingement. That's not good. That's like sandblasting the bottom of your lander, and you don't want to do that. Also, we'll have solar panels on board, so that way we don't have to rely on fuel cells. And as you can see here, it is absolutely huge. I cannot wait to see just what its cargo capabilities are going to enable us to do. Now, Artemis 3, our first mission to land on the moon. It's going to be about 30 days in duration, and there are going to be 4 astronauts, but like I said, only 2 are going to end up transferring to that actual human landing system and landing on the surface. And there's going to be at least 1 extravehicular activity, and they will be spending about 1 week on the surface. So we will certainly outlast the longest of the Apollo missions of Apollo 17 there. And there will at least be an unpressurized rover for travel. And in case any of you wanted to know, later on down the line, they are thinking about developing a pressurized rover, and NASA is actually in contact with, of all the companies, Toyota, to build a pressurized rover. I just think that's great because every country that wants to be a part of this is sort of throwing their own ideas into the mix. We have this really great political setup called the Artemis Accords, where countries that are interested can come to the NASA in the United States and say, we are interested in contributing to the Artemis missions, and then they sign like a memorandum of understanding, and then they can actually contribute something to that. So very excited about that. Now, your astronauts, it's sort of a who's who of new and old and great faces in terms of the skills and the technical abilities of them here. There are 18 astronauts total from the first Artemis crew selection. The chief of the astronaut office has said, though, that all of the astronauts in the total in the astronaut corps right now, which, by the way, it's 42 astronauts in the astronaut corps presently, 42, good number, that they're actually all available to go on Artemis missions, but this is going to be your core of the Artemis generation, if you will. So very excited about this, because going back to the moon, this is going to be one of our greatest adventures. You know, we were already on an adventure with Apollo. It really showed us what we were capable of doing when we put the best of the best into those places where it's needed to drive the technology, to drive the people, to drive the science in order to make it happen. So I'm really excited about it, because it's what spaceflight does. It brings the best of humanity, and it brings the best out of us. So timelines, we have to think about things with this. Artemis 2, that mission to do the free return trajectory and come back around from the moon, 10 days, that's set to happen in 2024. Artemis 3, our first landing since Apollo 17 in 1972. We're looking at doing that in 2025. But I do want to throw on the sort of star big question mark on this here, because there's a lot of things that have to go right. Budgets have to go correctly. Legacy contractors with the Space Launch System have to be able to sort of step up and get into the game with it. Legacy hardware has to work according to how it needs to, as we saw with the Space Launch System during the Artemis 1 sort of rollout and move and time towards launch, that there were a lot of bugs that had to be dealt with in the ground support equipment. I mean, that's what happens when you launch a new rocket for the first time. You will find every single bug, or hopefully every single bug on that flow eventually to launch. But there's also another factor too, which is different from what we had in Apollo. With Apollo being mostly a government venture using private contractors, some parts of Artemis are private contractors building private vehicles. And in this case, SpaceX, they're sort of the big, one of the bigger question mark factors involved in this because of their human landing system. They are certainly behind on where they were expecting themselves to be with their Starship Super Heavy launch vehicle. But I figure if there's any company or group in spaceflight that is really good at meeting the expectations of what their customer wants and other things, SpaceX is pretty good about that. So I always think it would be a bad idea to bet against SpaceX being able to do things with it. Them and JPL are my two never bet against in the space flight world. So that's what we're looking at in the future. It is bright. It is exciting. I absolutely cannot wait to see it. I was already excited watching my first moon rocket and my first, you go for TLI with it. I stayed up way too late to watch that. But now I get to see the first moon landing within my own lifetime. And man, I'm really excited about that.
I think you're right to be excited about it, because let me tell you, as an old man, they're pretty cool. You're going to have a lot of fun with this. We're all going to have a lot of fun with this. I think probably we should give our audience an opportunity. Should they have questions, we would be happy to look and see if they do. Yep. We're not booting out the door just yet. Do we have some? Oh, good heavens. We got lots of comments. Do we have some questions in there?
Good comments, but no questions that I saw while I was taking a look and moderating.
So I do see one. John asks, can computer graphics imitate the gait of walking on the moon? And that's true, they can. A lot of the modern computer graphics programs actually have physics engines built into them. So if something gets knocked over, it looks realistic. Movies require that. You don't have to do it by hand anymore. A lot of these programs will allow you to specify the gravity. We do know the gravity on the moon. So yes, it's true, they can. I will say, and you saw Jack Schmidt up there flopping around like a tuna in the bottom of a fishing boat. There's a lot of dynamics involved. It's not just as simple as when you hit the ground, your whole suit's going to be flexing and bouncing, and how soon motions damp out and things like that. So it's complicated, but yes, computer graphics do help, and I'm sure NASA's using them right now to help get us ready.
Yeah, one of the harder things to fake in terms of gravity and the moon environment is actually the lack of an atmosphere.
Yeah, the dust.
When you kick up the dust, that dust will go up, and then sure enough, it comes down slowly. But if there were an atmosphere, it would billow into the atmosphere and kind of hang in a cloud. That doesn't happen on the moon, and that's actually really tough to simulate. You could do it with a computer, but not with a sound stage. You can't do it with wires and things like that.
It's a good point for your no hoax thing. We literally, in those days, there was no way to do what happened every time somebody kicked the dirt. No way to do it.
No way to do it. And computers certainly couldn't simulate that back in those days. Even today, they're doing tricks and things in video games to do it live. And in computer, big CGI effects, they have finally, they're able to do particles in large numbers, but even still cloud work is, that's the stuff you got to have real expertise to do. I know our very own Patrick So often will go in there to do clouds at a distance for sunsets and things. And the renders take a ridiculously long time in our super powerful computer arrays. And they didn't have those back in the Apollo era.
No.
Jared, I had a question for you. We have a question from a David Pinsky. Will the astronauts be protected from solar flare radiation when they return?
Yeah, so that is something that we have to think about in when you're designing a spacecraft. Kind of important, radiation. As I was hearing from some of the engineers that work on it, there are two main sources of radiation to be concerned about with the astronauts. There's the Van Allen belts that you will have to go through on your way to the moon, and also solar or an increase in background radiation because of you being out of the magnetic field of the Earth, depending upon the mission that you're doing during the time period. So with the Van Allen belts, and this is something that's also often brought up by moon hoaxers, which is that there's no way, they did it because they had to fly through the Van Allen belts. Well, the radiation it can be intense, but you're flying through them in a matter of minutes to maybe an hour or hour and a half. So it's super fast in order for you to get through it. And then a lot of the radiation as well in the Van Allen belts can be blocked by material like the composites and the metals that make up a spacecraft at the thickness that they are. So it ends up not really actually being a big deal. But things like solar flares and other stuff, you do have to worry about because that's very local and that can be very extended. The best thing to do obviously would be to shelter in place, and they actually do have a collection of, I don't want to call it like a pillow for it, but it's essentially like these pillows that actually have mass in them that is made of a material that will stop radiation as much as it can from going through it. And there's also certain parts of the Orion capsule as well that the astronauts can go to that has a little bit more shielding than other parts. We already have things like that with the International Space Station. There's certain modules that are maybe half a millimeter thicker, simply to act as a radiation shelter in the event that an unbelievably potent radiation event from the sun would be able to impinge down to the International Space Station's altitude. So with Orion going out and being exposed like that, yes, the engineers have thought about that, and they basically have made a scientific version of a pillow fort in order for the astronauts to encase themselves in. And one of the things too on the Artemis 1 mission is that they have radiation detectors on the mannequin and all throughout the capsule that they were flying on it. And they're going to use that in order to figure out if they can actually add weight in the payload and see if they can strategically place certain items in the payload, like food and water and other things. Because water is a fantastic radiation shield. It's just that it weighs. It's got a lot of mass. So they're going to look at things like that and see if they can actually sort of move things around in the capsule once they get into orbit to provide additional shielding as well. Like, I had not even thought about, like, oh, well, if we put, the shaving cream right here, and the shaving cream and the toothpaste and then the water bag here, we can stop, X amount of radiation from going through this area of the capsule. Like they got a lot of smart people working on it. So
Yeah, that's fantastic. Folks, Jared, just so you know, folks are talking about raising funds to send you and your Jeep to the moon on an off-roading trip there. Just so we've started that.
I would do it. I'm for it. Let's make it happen.
I see a comment there that actually not a question, it's a comment that there'd been a lot of focus on Mars, and that's why we haven't gone back to the moon. I'll give you a little bit of ancient insight just very quickly from somebody who's worked in aerospace contracts for a long time. Contracts to do things and study things can be a useful way of keeping people busy for a long time, even if you don't end up flying. And with the switch from the moon, which is just 4 days away, to a focus on, no, actually, we're going to focus on Mars. There's a cynical part of me that notices you can do lots of studies and slow hardware development for a long time without actually having to do anything, because we're not really ready to go to Mars yet. It's a little bit like a president or somebody announcing they're going to build a bridge across the Atlantic Ocean. That can be a good contract for a number of years, but you don't really have the expectation you're going to do it. The moon's close enough at hand that, as you're seeing right now, if you commit to the moon, you're going to have to build rockets and you're going to have to fly them. And that's what we're doing right now. I think the moon's a good first step.
Yeah, absolutely. The moon is a great first step. I was also a fan of trying to go to a near-Earth asteroid before
I agree, yeah. Absolutely.
Going to Mars, but the DART mission has at least explored that sort of impact that the mission could have going to an asteroid. I had a question, just because we didn't, this talk wasn't designed to cover it, but we have a couple of moments. How does the Space Launch System compare to that Saturn V rocket, just in terms of capability? All these years have gone by. What have we gained, if anything? What's the status of the SLS?
Well,
Jared, you're the one that might be the most knowledgeable on this, by the way.
Sure. With the Space Launch System and the Saturn V, if we're going to compare the two, the Saturn V was essentially brute force to orbit. I mean, I don't necessarily want to say that the Space Launch System is elegant to orbit, because it's also got some brute force with those two solids that it has on it, which the solid rocket motors that it has are derived from the shuttle. They are 5-segment solid rocket motors. The shuttle used 4-segment solid rocket motors, so they've got an extra segment, and there's also a little extra kick as well out of them. And then also the Space Launch System is a little bit has a little bit less work done on the core stage, because with the Saturn V, there really was a lot of this has never been done before, so we have to figure out how to do this. There's some really great documentaries out there that I highly recommend if you're very interested in it. There's one that's actually specifically about the first stage of the Saturn V, because that was a massive technological undertaking with that, just to get the engines to work correctly, to make sure that everything was going to be able to actually make the rocket move, like gimbal, right? Like actually, it was just difficult all around, because these were things that just had never been done before. The technology had to be invented, the materials had to be invented, the operations had to be invented. So it was all new. It was all fresh. And with the Space Launch System, I don't want to say that there's nothing fresh about it, because there's lots of new ideas in it. But at the same time, it's also legacy hardware. It is shuttle hardware that is ultimately being used. Parts of the casings for the solid rocket motors flew on shuttle missions. Those 4 RS-25 engines at the bottom of the core stage were flown on shuttle, and they have now had their Viking funeral by being burned up in the Earth's atmosphere and never being used again. And we thank them for that. Also the core stages as well, the Space Launch System are essentially a extended shuttle external tank. They're even built in the same facility at Michoud down in the south, where the shuttle external tanks were built at as well. So Saturn V was about as fresh as it gets in terms of how we had to develop the technology for it. Space Launch System, a vast majority of that technology and our operational understanding and other things was there. And I feel like that's where a lot of the criticisms of Space Launch System come from, which is that we already knew how to do this. So why did it take so long? Why did it cost so much? And all those other ways of it. Chris, I saw you make a move there, looking around with it. Like maybe you've got a little extra to add on to kind of the perspective here with that, or not. With it. So yeah, I mean it's all in the perspective. Mine at least with that is that Space Launch System was started well before commercial space had even reached a period before maturity. SpaceX hadn't even SpaceX had just barely successfully flown a Falcon 1 around the time that Space Launch System was solidified. So we weren't even in the Falcon 9 era at that point, let alone landing them consistently like they are nowadays. So it is a relic of a previous time, and I imagine that Space Launch System will probably be the last of its kind.
Yeah. Well, Chris, final question for you that I have is, you like to think of Apollo 17 as, in very much in your presentation, you were talking about it being sort of the end or the beginning or the end of a beginning, really, or this is a stepping stone into the future. Did you think it would take this long to get back to the moon?
No, I really didn't. And you even heard the crew. They're talking from the surface of the moon. They were debating about that. And Jack Schmitt said, no, we should have just kept going. We should have kept going. My guess for a return to the moon, you ask 8-year-old Chris, I would have said, it's going to be a while. It'll probably be 1985, maybe 1990, something like that. And indeed, we've talked about it many times where it looked like it was going to happen. When I worked on the shuttle in 1989, they had the big thing that President Bush 41 had announced. We were actually going to build a sustained base. We're going back to the moon, back to stay. I remember the speeches. And it just evaporated. After that, I started to get pretty cynical about it, because somebody would propose a program and it would evaporate. And that happened a couple times. I never dreamed I would be 58 years old before some of this started to happen again. But I'll tell you, I sure am glad. I'm not going to look a gift horse in the mouth. Maybe a little late, but we're back in the game.
Yeah. Well, I think that about wraps up our presentation for today, everyone that's joined us. I appreciate everybody that joined us on our YouTube stream and on our comments. The chat's always fun. If you're wondering where we're getting these questions from, you need to make a YouTube account. You can log in and you can also chat with us on the YouTube chat. By the way, keep in mind, this is our last presentation up until we'll have our winter solstice on the 21st of December. So look for that coming up on your YouTube stream. So we do have that to look forward to. This is the last presentation from us until then. And then that, I guess, will be the last one of the year. I almost said this was the last one of the year, but it's not. We will have an all space considered in January. I don't know if we have any special guests for that or anything, but I just want to make sure I thank our foundation members, everyone that's made a donation that helps keep our foundation funded, that helps keep Griffith Observatory able to do programs like this one. And also the City of Los Angeles, the Department of Recreation and Parks, and Griffith Observatory are the ones responsible for this program today. And thank you, Chris, so much for putting this together. And thank you, Jared, for joining us and with all your wonderful knowledge of the Artemis program. And I'll just say one more time, this wasn't hoaxed. We really did go to the moon. We really are going back to the moon. And I think that celebrating these facts can really help bring us all together and unify us. And Griffith Observatory is the location that we will keep you looking up and keep you looking at the skies. So thank you so much, everyone, for joining us, and have a wonderful rest of your Sunday.
Thanks, folks.